Okay, we're going to talk about the unit circle, 9.2, day 4. Take out your notes. Get a little different order than what's in the notes, so we'll skip these warm-ups. Head on over to, I think it might be your back page. It looks like this. We're going to start here. We'll work back to that other unit circle information that's also in your notes. So the key to the unit circle, the whole important piece is, it's a unit circle and it has a radius of 1. So we are going to be able to guarantee that our radius or hypotenuse is always 1. That's going to be great for us because if you remember back to what we did earlier, we knew that the sine was equal to the x over r and the cosine was equal to y over r. If you don't remember where that came from, remember, anywhere on here I go x over y up, Pythagorean theorem gives you the r, and we were able to say that the sine was the opposite over the hypotenuse y over r. The cosine was the adjacent over the hypotenuse x over r. So we're going to focus on sine cosine for now. So now, if we're going to dictate that the radius is always going to be 1, then we are going to be able to dictate that the most important thing here is the sine is always going to be simply the y coordinate, because if the r is 1, then you are guaranteed, whoa, that's ugly, that the sine is the y coordinate and the cosine is the x coordinate because you're dividing by 1. So when you look at this little guy over here, instead of an x value and a y value, we actually have the cosine value and the sine value. Okay, so now these are a little bit cumbersome. It says the terminal side of an angle in standard position intersects the unit circle. Please make note this only works with the unit circle. Since it's the unit circle, the cosine is the x coordinate. So in this case, the cosine is square root 7 over 4, and the sine is the y coordinate, which is 3 over 4. Okay, so all you have to do, if you know you're dealing with the unit circle, because we know it's the y divided by r and r is 1, it's just the y coordinate. It's really going to help us out with these ones that fall on the axes. Remember, those are called the quadrantals. That's going to be our main focus with these guys, but we have a couple of extra things we do as well. Now again, in order to do these problems, you can't mix up the problems from previous units in this unit. This says unit circle. That means that the r is equal to 1. And that's why we can say that the sine is the y coordinate, in this case negative 1/4, and the cosine is the x coordinate, which is square root 15 over 4. Okay, so you're looking for the unit circle, and it's just x coordinate is cosine, y coordinate is sine. So on the previous one, they had the ordered pair can actually be replaced with the cosine or the sine. I can't stress enough that this only works for the unit circle. When we talk about this big nasty unit circle here, then we're really talking about x coordinate, y coordinate, and since I know that the sine of 30 degrees is equal to 1 over 2, and the cosine of 30 degrees is equal to the square root 3 over 2, then I can actually go over here. This whole unit circle here could be filled out, since I know all of these radii are 1. As we move all the way around the circle, the radius doesn't change. And you could actually make ordered pairs with all of these guys. Well, we already have a good method for doing our 30s and 45 and 60s and chilling in the STC and using our 2 important triangles. So we have a way to do those. You're really going to find your best usage of the unit circle right here. And this is going to be where, if I'm looking for the sine of 0 degrees, that's going to be the y coordinate, which is 0. So this makes things go very fast. The cosine of 0 degrees is 1. It's the x coordinate. Okay? You can do tangent with this stuff as well. the tangent of 0 degrees. And we must remember the tangent is always the y over x. If you remember that it's always going to be the sine over the cosine, that's a great way to do it. So you get 0. And then we can flip these things over and do those cosecants and things like that as well. So I do the cosecant of 0 degrees is going to be undefined. And then the secant of 0 degrees is going to be 1, because I'm just flipping it over, and the cotangent is going to be undefined as well. And we could do all of those. So you're just focusing on so if I was talking about 90 up here, I'm talking about this has got to be the cosine because it's the x coordinate. This has got to be the sine. So we could do that all over the map here, okay? And technically you could fill in all of these other ones as well with things like 30 degrees is going to be, the cosine is square root 3 over 2, and the sine is 1 over 2. And we go to 45, and if you remember, 45 is 1 over the square root of 2, or square root 2 over 2 with both of them. And really, if I just do these first three, and the 60 degrees, the cosine is 1 over 2, and then the sine would be square root 3 over 2. And if you think about the STC, then all of these x coordinates over here, or excuse me, y coordinates are going to be positive over here. I would have a positive sign and a positive sign and a positive sign because the y coordinate is positive. I have a negative on the cosines. Down here they're both negative. How come? The tangent is going to be negative or positive in quadrant 3. All the rest of them are negative. And it's these same ordered pairs just going all the way around. So there's really not 16 ordered pairs here. There's basically a derivation of about 5 of them is all it is. And over here the cosine is positive. So your x coordinate is now positive, which should make sense because we are to the right. We're to the right of the origin. Okay, and this comes back to our STC, and we won't stop using that stuff. You'll use that throughout your math career. Okay, so where is the unit circle the most important? It's right here. We need to understand that the sine of this guy is always the y coordinate. The cosine is always the x coordinate, and the tangent, I like how these line up nicely. It's the y over the x, and that's just how they're written right there. So it's a very easy way to remember it. So now, if I'm looking for the missing points, the sine of 180, I go down to 180, and I know I'm looking for the y coordinate, and that's going to be -1. The tangent of -360, well, first I have to see where I land for -360. I'm over here at 0. And of course, -360 is coterminal with 0. And I'm talking about tangent now, which is y over x. That's going to be 0 over 1, which is 0. And then the cosine of 270 all the way down to the bottom here. Cosine, x coordinate. The x coordinate straight down, 0. Cotangent of -270, I don't ever deal with cotangent. I think cotangent can be a pain. So cotangent of -270, negative means I'm going around this way. I'm coterminal with 90. And again, I'm going to do y over x for the tangent, which is 1 over 0, which is undefined. And when you flip over an undefined, you get a 0. And it's just lovely. Tangent of 90. Again, I just did that one. It's the same thing right here. Tangent of 90 is coterminal with -270, so I know I'm going to be 1 over 0 or undefined. And finally, the cosine of -180. -180 and 180 are the same thing. Cosine is the x coordinate, -1. So if you're looking for a quick way to do the ones that fall on the axes, the quadrantals, you can find it pretty quickly just by sketching this and writing in the 4 important points, and then remembering that the sine is the y and the cosine is the x and the tangent is y over x. Do you really need to remember it, or could you actually, while you draw it, say, okay, I'm going to put a 1 there, I got an x there, I got a y there. And you can very quickly come up with the fact that the sine is the y coordinate and the cosine is the x coordinate based on SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse. And there you have it. Okay, last thing for today, we're going to go back to what we did in our day 3 with finding our exact values, but now we're going to do some operations. So notice it's asking me for the sine of negative 210 plus 3 times the cosine of 30. So I'm going to get a ratio here plus 3 times a ratio here, and then I'm going to solve a math problem. So I'm going to start with negative 210, and I'm going to go backwards around to here, which is going to give me a quadrant 2. Quadrant 2 for sine, again, STC. We do the same thing again and again, and I get I know this is going to be positive. You do not have to write the plus there. You could write it up there. That would be fine. And then I get the reference angle is a 30-degree angle just passed in quadrant 2. I grab my reference triangle, which, you know, one of the few things we ask you to commit to memory is 1, 2, square root 3. And I know the sine is going to be 1 over 2. So I know this is positive 1/2. I have to get that plus sign out of there. It's going to bother me. So I'm just going to erase that real quick. Bear with me. In the meantime, let's see if we can figure out what the cosine of 30 is. Cosine of 30, quadrant 1. Everything in quadrant 1 is going to be positive. I know this is going to be a positive. I go to my 30-degree angle, adjacent over hypotenuse, square root 3 over 2. And now I just do the math problem. So we do have some fractions here to add, and that's okay. Don't be scared. And I get 1/2 plus square root 3 over 2. I already have a common denominator. This is technically a correct answer. I would clean it up just by putting it all over 2, and now we're done. We can't add the whole number 1 with a square root, so we're okay. Same thing over here. 6 times some value times some value. Does look like I'm going to need a 45, 45, 90. Again, hopefully you've committed that to memory. 1 square root 2. And then I'm going to figure out sine of 45. 45 is going to be quadrant 1. Everything's positive in quadrant 1. I get 1 over the square root of 2. Remember, it is 1 over the square root of 2, but a little cleaner way to write it is square root 2 over 2. And look at that. That's going to cancel out nicely. It's going to be great. And then I can do the tangent of 300. Tangent of 300, that's all the way into quadrant 3. Chilling in the STC. This is going to be negative. So I'm going to have a negative answer in there. And I'm going to have, now I have to do the tangent of 300, which is a 60, right? It's a 60-degree reference angle. 60. So I'm going to stand here. I'm going to go square root 3 over 1. Square root 3 over 1. And now take a look at what happens with it, because this is technically 6 over 1. 6 over 2, that's the number 3. And then I've got a negative, and I've got a 3. And you can actually multiply root 2 times root 3. Root and tootin', it's root 6. Okay? So we figure them all out separately, and then we just do the math. Again, we shouldn't have a decimal for any of these answers because they're asking you for an exact value. So the biggest thing from today is, as you go around a unit circle, you need to understand that you've got these nice quadrantal angles, and that's the best, 0, 1, excuse me, I almost made my first mistake of the day. And then we've got negative 1, 0, and 0, negative 1. And those ones are going to be the most useful pieces of the unit circle.